horizontal velocity is involved for range u of x. You want to look at the horizontal distance it takes the body to move from here to here. So that distance takes a total time t to occur, total time, which is time of flight. So you have time of flight involved, you have u of x involved as well. So for range, u of x is there, time of flight is also there as well. U of x, don't forget, which is equal to u cos theta, c, which is equal to 2u sin theta over g. Now the what's it called now? Now, so I've moved from here to here. How do we get this distance? Distance is just a product of what? A product of velocity and time. But actually here, should we call it distance, but rather a more of a displacement? Yes, a displacement simply because we have importantly vector quantities involved. So we want to calculate for the displacement it takes for the body to have moved from point A to point B. So the displacement, which is also a form of distance, but in a what? In a specific direction. So that displacement s is equals to, okay, let me see, that displacement is equals to the velocity multiplied with that total time. What's the displacement again? It is r in that horizontal axis. So that velocity it takes is that your u of x, right? And then multiply with time. Total time is that time t. So you have this to be, this is u cos theta, and then you multiply this with your 2u sin theta over g. So all in all, what you have here is the fact that everything turns to be 2u square sin theta cos theta over g. So to further simplify this, there is an identity, to put in 2u sin theta cos theta. There's an identity that says that sin 2 theta is equals to 2 sin theta cos theta. So we can say, since sin 2 theta is equals to 2 sin theta cos theta, so this becomes u squared. So meaning that you're going to take out sin theta, you're going to take out cos theta, so you have u squared remaining, and then bring in that identity sin 2 theta over g. So this is for range. This is for range. So I think with that we've been able to get some of the important things that we need to know. Okay. Yeah, where were we? We were here. So don't forget that I mentioned that discussing linear motion, or if whenever you want to solve a linear motion question, you must first identify your given parameters. Is u given? When u is given, is it stated that it is at rest? If it is stated that it is at rest, u will be taken as 0. You must look out for final velocity it is given, look out for time, look out for height, look out for acceleration, look out for everything. So all of those things will be able to point you in the direction of which of the formula of linear motion should you apply. Do we understand what I'm saying?
Yes, sir.
Okay. So
Yes,
all of these ones that I've been mentioning, that I've been explaining since, are all under the field of kinematics. They are all under kinematics, which is the study of motion without making reference to the force that actually causes the motion. However, if at any point in time you want to talk about the one that has to do with the study of the motion and the cause of the motion, that is the case of dynamics. So in dynamics, you want to know what force is involved, whether the force will be sufficient to cause the motion or the force will not be sufficient to cause the motion. I will come again. All of these things we've been explaining here is under kinematics, which is the study of the motion without making reference to the force causing the motion. However, if we need to study motion making reference to the actual force causing the motion, that is dynamics. Okay, so in dynamics you want to study force, so meaning that you must be familiar with the force formula. Okay, the force formula you must be familiar with the force formula, right? So this force formula is F is equals to what? Ma, as is mass multiplied with acceleration. Measured in what? Newtons. The unit is kilogram meter per second square or Newton. So please do not forget that this force is also a vector quantity as well. So you probably can have, or you can write your R edible. It's not really important per se whenever you're writing. Let's say you're writing an example. You know, it can take your time. You can take your time while solving also. So, but if you write it this way, it is not bad. So a very important scientist, Isaac Newton, gave us a very important law, or very important laws that you need to know. Those are called the Newton's laws of motion. Okay, so these laws of motion are divided into three. Importantly, you need to know them. So number one is called the law of what? The law of inertia. So what is inertia? Inertia, you probably have been hearing about it long time ago. So inertia is just the tendency of a body to remain in a state of rest or in a uniform motion. You can write that here. Inertia equals tendency of a body to continue in a state of rest or uniform motion. So what is this law of inertia talking about? This law of inertia states that a body will continue to be in a state of rest or uniform motion unless acted upon by an external force. Body will continue to move, to be at rest or uniform motion unless acted upon by an external force. So acted upon by an external force, that is that. So meaning that an external force is going to cause it to change otherwise. Okay, so the second one, you have the law of the actual formula. Let me say we can actually call it law of momentum impulse relation. momentum impulse relation. So what does that state? So what it's telling you is the fact that the force that tends to cause the motion of a body is directly proportional to the rate of change of the velocity. Rate, when they say something rate, it means something divided by time. So rate of change, when they say change, change means difference in two given values. So rate, I said something over time, sorry. So rate, I said something over time. Rate of change, the force that tends to cause the motion of the body, is directly proportional to the... Sorry, please, can you all give me a few minutes? Can you all hear me?
Yes, sir.
Give me,
Yes, sir.
give me a few minutes, please.
Give me a few minutes.
Ultimately.